SpaceX recently brought a revolution in the field of the space industry. The transformations which we've witnessed recently in Starship's technique and its outer appearance are beyond imagination, and we're sure that you would have not expected such a drastic development in such a short span of time. The advancement has no doubt brought challenges for the other industry players who find it difficult to be recognized before SpaceX Starship. What is it that has caught the eye of all in these recent developments of the Starship? Is this SpaceX gained mastery of Starship's welding technique? Indeed, but to check out how, to stay tuned till the end of the video. It is quite clear that the Starship, till now, didn't look very attractive and smooth like other rockets usually do. But what could be the reason behind it? Originally, the attempt was made to construct a Starship using carbon fire. Despite being exceedingly strong, carbon fiber disintegrates at 200 degrees. Therefore, in order to survive the 1600 degrees during several re-entries, an extremely thick heat shield would be needed. Even though stainless steel is heavier, it can withstand significantly greater temperatures, necessitating only a very thin heat shield. Additionally, stainless steel is much more affordable than carbon steel, costing only $3 per kilogram as opposed to an astounding $150. It appeared to be a great idea, and the productions accordingly spiked owing to the same. But then what did exactly change the Starship welding technique, leading it to be made up of stainless steel? In order for a material to be strong in all directions, the fibers must be layered very precisely when creating carbon composites. The composites must then be cured in a large pressure oven. But the size of the oven needed by SpaceX for this purpose would require an oven that is much bigger than anything that is now available for its 9-meter broad part of the vessel. Surprisingly, stainless steel then came into the picture. It is simple to assemble using the most straightforward and inexpensive technique, and this is precisely what motivated SpaceX to start working with this shiny material. But the biggest hindrance in this way came from welding. Each ring was initially constructed from many 4.5mm thick sheets of stainless steel. But considering the fact that the original spaceship crew lacked experience in this area, the welding standards were apparently subpar. But then the question arises, what's so tough in this welding process? Initially, the welding technique used for such purposes was that of flux-core arc welding. Electric arc heat is used in flux-cored arc welding to melt base metal at the weld junction. A weld junction is created when an arc is created between the metallic workpiece and the constantly fed tubular cored consumable filler wire, melting both of them together. For welding thicker materials or out-of-position welding, this dual shield technique is ideal. When applied under the same conditions, this method produces welds with more uniform mechanical characteristics and fewer flaws than the manual metal arc or metal active gas processes. Higher production rates than with solid wire or stick electrodes are also possible with the constantly fed tubular electrode. But the major problem in this process was that the gas-shielded process is not appropriate for usage in windy conditions, since the disruption to the gas shielding causes a reduction in the characteristics of the weld metal. Thus, this welding technique did not culminate into a very desirable result. The prototype, as it was created, had severe surface corrosion, fissures, and jagged edges. SpaceX began polishing these welds down until they were flat with the surface in order to enhance them. Although it appeared that this was a feeble attempt to restore some shine, the process was actually carried out to fortify the walls. Once the ship is pressurized, the little cracks and sharp edges acting as pressure points could cause much larger cracks. Thus, polishing the surface removed the flaws and decreased the likelihood that the weld would fail. The fact that Mark I exploded by utilizing the same welding procedure, however, did not prove that the premises were true. This alerted SpaceX, and they began a work in order to enhance the next Starship prototype. Each ring was now constructed from a single, thinner sheet of stainless steel, requiring substantially less handling. At this point, they updated the tip TIG welding and switched from 301 to 304 L steel, which was more resistant to corrosion in the welding process. Tip TIG uses a filler wire agitation mechanism to improve the dynamics of the molten weld pool. This agitation increases the fluidity of the weld puddle, releases developing gases, lowers the likelihood of inclusions and porosity, and also separates impurities. Tip TIG welding systems also cause the wire to vibrate and apply hot wire current to the filler metal before it even touches the weld pool. The mechanically applied, Linear forward and backward motion of a special wire feeding system causes the vibration, which leads to higher welding speed. But most importantly, this method produced much thinner welds and didn't wrap the surrounding metal as much. SpaceX also tried robotic welding machines, and to some extent laser welding as well, which has definitely helped them to construct somewhat cleaner, stronger, and smoother walls. Robotic welding is a highly developed form of automated welding in which welders maintain control and oversight of the operation. Robotic technology enables accurate and speedy outcomes, less waste, and more safety. Robotic welding is faster than manual welding because it can access previously unreachable places and conduct intricate and exact weld lines. This offers more flexibility and frees up time for production. On the other hand, laser welding is more frequently carried out by adopting a keyhole mechanism and larger power densities. The material in the path of the laser beam melts and vaporizes when the laser beam is focused on a small enough area to provide a power density before substantial amounts of heat can be dissipated by conduction. The concentrated laser beam enters the workpiece and creates a keyhole cavity filled with metal vapor. The molten walls of the keyhole and this cavity are kept from collapsing by the increasing vapor or plasma. Additionally, the creation of this keyhole significantly enhances the coupling of the laser beam with the workpiece. The joint is then moved in relation to the laser beam or traversed along the joint to be welded in order to accomplish deep penetration welding. This ultimately results in welds with a higher depth-to-width ratio. You might have been impressed by the advanced welding techniques used by SpaceX by now, but surprisingly, this was not it. SpaceX later moved on to cold rolling techniques. In this method, before being employed on the spacecraft, the alloys that are used on specific rocket components have a cryogenic treatment. It is anticipated that this method significantly reduces the weight and wear resistance of alternative steel options, such as hot-rolled steel, by cold forming the metal into cryo-treated steel. Before being employed on the spacecraft, these alloys that are used on specific rocket components have a cryogenic treatment. It is anticipated that this method significantly reduces the weight and wear resistance of alternative steel options, such as hot-rolled steel, by cold forming the metal into cryo-treated steel. Although the aerospace industry has always used steel, cold-rolled steel has recently received greater attention than in the past. Traditional hot rolling procedures are extended by this rolling technique by an additional stage. Steel that has been hot rolled is rolled once more at room temperature after it's cooled. This facilitates obtaining precise dimensions and enhances surface quality. Because they are formed at lower temperatures, cold-rolled steels are also stronger than their hot-rolled counterparts. But when Starship is welded, the heat makes the metal even softer. This is when the SpaceX huge planishing machine enters the picture, which entails hammering down and compressing the walls until they're as rigid as the metal surrounding them. This also improves the appearance and smooths out the surface of the walls. The updates in this field also report that SpaceX is in the process of developing its next-generation spacecraft. Moreover, SpaceX aims to reduce the cost of rockets, and if there's an industry that mastered the art of making complex vehicles cheap, it's certainly the automotive industry. That time is not very far when SpaceX might really end up making the best Starship and the most popular welding techniques. So should we believe that this is the best shining wall the Starship can get, or is there a possibility of further improvements? Well, to answer that at this level is quite tricky, because in order to achieve something more advanced than what already the Starship looks like right now, it'll have to undergo an entirely new process now. But anyway, as mentioned earlier, SpaceX is pouring everything into Starship, and it's incredible to watch this project come together so swiftly. After all, it cannot be denied that it has gained mastery over Starship's welding technique. So, well, this was all. We hope that you enjoyed such an informative video and are still expecting the advancement of the Starship into its highest form. While this is yet to be seen, we bid adieu till we come up with more such content on interesting topics. If you enjoyed this video, don't forget to like and share. Also hit the bell icon so you don't miss any videos because we have a lot more interesting things to come.